Hello, everyone. In this video, we're going to look at example 3 in section 12.1 to 12.3. So in this example, we're looking at a function of two variables, and this function is given to us in this table. So to get an idea of this, let's read the question first, or read the example, and then we'll unpack how this table can be used in this problem. So example 3 says, the wind chilled temperature is a temperature which tells you how cold it feels as a result of the combination of wind and temperature. So we're going to let C equal the function evaluated at W and T, where C is the wind chill temperature in degrees Fahrenheit that is associated with a wind speed of W miles per hour and a temperature of T degrees Fahrenheit. A table of values for the function F is given to the right. So let's go ahead and unpack that table and try to make sense of this situation that we're looking at. So in this table, notice this upper left corner has a W/T. So how we read that is that this big T is representing the values in the columns. So here, this would be big T, or the temperature is equal to 35 degrees Fahrenheit. And then W is the variable represented in the rows. So 20 here would be 20, in this case, W, which is miles per hour. All right. And then now if we look at any cell, so say when W is 10 and T is 30, the output would be given is 21. So inside this table, these are the big C values, which is the wind chill temperature. Okay. And so as we're told, and you might have experienced this before, the temperature can feel a certain way outside. That's the wind chill. And that feeling is a function or is based on both the wind speed and the actual temperature it is. Okay, and so that's what this function F is giving. Function F is giving us that wind chill temperature depending on the wind speed and the temperature outside. Okay. So feel free to pause the video and think about this table a little bit and the discussion we just had. And then when you're ready, let's look at part A. So in part A, we're asked to evaluate and interpret f of 20, 5. So let's unpack that a little bit. So here, 20 is the W. So this would be W equals 20 miles per hour. And 5 is representing the temperature. So big T is 5 degrees Fahrenheit. So then how would we evaluate f of 25? 20, 5. Well, we can look at the table. So let's first find when W is 20. We see that that's here. And then when W is 20, let's find when the temperature is 5. So that's over here. So we can go over 20 for W, 5 for T, and we see that negative 15 would be the value of f of 20, 5. So I'm going to write that down. So we have f of 20, 5 is equal to negative 15, and that would be degrees Fahrenheit. Okay, so now let's go ahead and interpret what that means. So to interpret, what we need to do is unpack what each of these variables is representing. So as we saw already, W is the wind speed, T is the temperature, and then that output, negative 15 degrees Fahrenheit, is the wind chill temperature. So we can interpret that by saying, well, when the inputs, or when the wind is at 20 miles per hour and the temperature is 5 degrees Fahrenheit, it's going to feel like it's actually negative 15 degrees Fahrenheit. Okay, let's go ahead and write that down. So when the wind is blowing at 20 miles per hour, and the air temperature is 5 degrees Fahrenheit, the wind chill, or what it feels like, the wind chill temp is negative 15 degrees Fahrenheit. Awesome. So that's how we can interpret that value of F at 20, 5. All right, now let's take a look at part B. So in part B, we're asked, how fast does the wind need to blow? So that's the W, how fast the wind is blowing, for it to feel like negative 20 degrees Fahrenheit. For it to feel like that, that's going to be the wind chill, when the air temperature is really 5 degrees Fahrenheit, which is our temperature T. So what we're asked here is to determine what W is going to be when the wind chill is negative 10 degrees and the air temperature is 5 degrees. So let's set that up using notation. So if we're looking at our function F, well, we are told what C is, so that's the output. So we're told that F is going to be negative 10 degrees. For an input of T equals 5 degrees, and for what W? So in this question, we need to find the W here. So that's what this question is asking. So we need to solve for W. So how are we going to solve for W? Well, we're going to look at our table. So in our table, we're going to look at when the temperature is 5 degrees. So we go up here to the temperature column and we see 5 degrees. So we're going to look at when the temperature is 5 degrees. And we're looking for the wind chill to be negative 10. So in which row is the wind chill negative 10? It's right here. So we're going to highlight that, negative 10. So at what W does that occur? Well, we can go along to find that W. And that W is at 10 miles per hour. So we can say W is equal to 10 miles per hour is the necessary wind speed. We want to say more, it's the necessary wind speed to make it feel like negative 10 degrees Fahrenheit when the air temperature is 5 degrees Fahrenheit. All right, great work working through this example.